Hello, my name is Claire Donald and I am a lecturer in microbiology here at the University of Glasgow. It is my very great privilege to be here to present the results of our cross-college scholarship project, which is about the impact of using virtual reality to teach microbiology online. First though, in order to do that, I need to take you back to early 2021 when the university campus is effectively closed in terms of teaching, and instead software packages such as Zoom and Microsoft Teams have replaced lecture theatres and laboratory classes. So within the life sciences, one of our greatest challenges during this time was to adequately support our students to develop the necessary practical skills required for their future careers. This, as you can imagine, was a very daunting task when all of our students were comfortably learning from home with no access to basic pieces of lab equipment. Fortuitously for our team, back in 2017, before SARS-CoV-2 was even a thing, our team successfully competed in a university-wide competition to have a virtual reality application designed for us by the leading immersive technology company Edify. We were one of just 10 apps that were selected, and our design was to be embedded within the Molecular Methods third year junior honours course, which is the largest practical course delivered to life sciences students at the University of Glasgow. Our aim was to use the app to overcome a number of key pedagogical boundaries that we encounter within traditional large group teaching in laboratory sessions. If only we knew back then how important this app was going to be for our teaching. So the third year molecular methods course was the ideal course to embed this VR taught component. As I said, it is a junior honours course, however, it is also offered to postgraduates as well as third year undergraduates, and so we have approximately 500 students enrolled on it every year. As it's a compulsory course, every third year life sciences student must take it. So we cater to students with a wide variety of backgrounds in molecular biology. As a result of this, we do struggle to get some students to fully engage with the course content because they don't see how it directly fits with their chosen degree subject. So the inclusion of novel teaching techniques could be really helpful in improving their understanding and engagement with the course material. Now that I've introduced you to our study, allow me to take you on a guided tour of our virtual reality research lab environment. You've now entered what we call our disease diagnostics laboratory. The environment itself is modelled on a research lab at the University of Glasgow's Centre for Virus Research, which is up on the Garscube campus. And for many of our students, this will be their first glimpse into what it is like working in a research lab. After entering the lab, the students are presented with these on-screen blue instruction icons, which provide a step-by-step guide to each action which is required while they're in the app. It reminds them to follow basic lab etiquette, such as washing their hands and putting on a lab coat before they get started, up to using expensive and hard-to-get equipment that they wouldn't traditionally have access to in a traditional teaching laboratory class. The main technique that this application focuses on is called qPCR, or Quantitative Real-Time Polymerase Chain Reaction. Within our VR app, it's used as part of a scenario where the students must diagnose two individuals who have presented with symptoms of a viral infection. The students are given samples from each patient and follow the instructions to guide them through preparing a qPCR reaction. The qPCR experiment will amplify nucleic acid from part of the virus genome and determine if it is present in the samples obtained from each patient. On completion of their experiment, students can visualize their results within the app, but then will be provided with the same data afterwards in order for them to analyze it and reach their diagnosis. This is particularly beneficial for us as it allows our students to see the entire workflow and how it all links together, which is something we know that they struggle with during in-person labs. Various editions of our app were developed over a couple of years, and the academic team fed into each iteration throughout the design process. Although the app was initially designed to be used by students in person, of course, understandably, the COVID-19 pandemic forced Edify to change tack slightly, and instead they'd changed their development into something that could be used by proxy. This meant that the students were working from home and would be able to log into a Zoom call as part of a small group with a member of staff who was wearing the VR headset at home. Much like you are right now, the students would be able to follow through the processes involved as the member of staff performed them within the VR environment. With the aid of the on-screen instructions, the lecturer is able to talk the students through each step of the experimental process and describe the potential pitfalls or common errors. We also had a second member of staff who supported the Zoom call on the chat to answer student questions and provide responses or clarification in real time. Following the lesson, both staff were then available to answer questions about the methods that were discussed during the VR app, as well as to facilitate more general discussion around other topics covered during the course or careers advice. So this gave our students some much needed interaction with staff and peers. The VR experience is accompanied by an interactive online lab book, which students worked through before the lesson to ensure they had a good understanding of the procedures covered. It also supported the students as they analysed the data they gathered. The book comprised of topic-specific worksheets, videos, quizzes, and interactive learning science simulations. These covered a range of techniques, including diagnosing an infected patient using qPCR, which is of course the topic covered by this VR experience. All the students were provided with structured access to the activities within the Moodle book, so it was split into 5 chapters to be completed over 5 consecutive days. The VR experience was then offered on the 5th and final day. The Disease Diagnostic Scholarship Team has been investigating if this VR technology influenced the student learning experience by comparing VR delivered by proxy to more traditional and less immersive online teaching methodologies, in this case, the interactive online Moodle book. Our study focuses on the use of the Molecular Methods VR app to effectively teach practical skills to our students whilst they were working remotely. We decided to specifically look at student confidence, knowledge acquisition, and enjoyment of the learning experience. To do this, we split our 76 participants into 2 groups, a test group who experienced the VR incorporated within the interactive Moodle lab book, and a control group who only worked with the online interactive lab manual during the lesson and who then received the VR experience later after the lesson was complete. Our participants completed questionnaires before and after these tasks, and both groups were invited to attend focus groups to provide more detailed feedback around their thoughts on the experience. Unfortunately, our study received poor interest from the cohort of Level 3 students we invited to participate, and so we repeated the study with Level 2 student volunteers. The results we obtained indicate that although both the Moodle book and the VR lesson increased students' confidence in performing the techniques that we covered, this was shown to be statistically significant in the VR test group in 3 of the 4 measures we tested for. We also found that although there was no observable difference in learning outcomes between the 2 groups, students in the VR test group consistently rated their learning experience more favourably than the control group, with many saying that they felt more present and engaged with the material when the virtual reality experience was included. Many of the students we surveyed had never used virtual reality before, but they said that they wanted it to be used more frequently within the curriculum. While the majority of the feedback we received was generally very positive for the VR by proxy, there were some students who found the experience too overwhelming or nauseating, which is something that we need to be mindful of when we go forward. So to conclude, our study has found that using virtual reality by proxy is an effective replacement for lab-based teaching when used as part of a distance learning method compared to less immersive technologies. In particular, we found that our app improved student confidence in performing the key techniques included and improved their engagement with the material. We are currently using the app as intended as part of an in-person experience down in the multi-user VR suite in the Partick Borough Halls. But this time we hope to evaluate its use as a pre-lab training tool to improve our students' confidence before they go into the in-person lab classes. Finally, we hope that this is just the beginning and we can develop other virtual reality apps to further support our students with other concepts in the future. So with that, it just leaves me to thank all of my collaborators who were involved in the disease diagnostics app from the College of MBLS, the College of Arts and the College of Social Sciences, as well, of course, as our collaborators over at Edify. Thank you very much for listening, and I look forward to discussing our project with you further.